Probability, fundamental principles of probability. Here we're going to look at a number of principles of probability relating to counting. Counting the number of ways something can happen. And there are two important words we use in probability, the word and the word or. So when one operation has m possibilities and a second operation has n outcomes, the total possible outcomes is m times n. The first operation must be performed before the second operation. So here in this section, we're talking about more than one event, more than one outcome. We're saying this happened and this happened. So there are two things happening. And we actually just multiply the two things together. There's also a principle called the OR principle, and it says when one operation has m possible outcomes and a second operation has n outcomes, the number of possible outcomes of the first operation or the second is given by m plus n. So, do you use multiplication or do you use addition? Well, here it's saying for the OR, you're using addition, and for the AND, you're using multiplication. And let's see how that might work. There are two formulae there as well, relation to and or, and we'll come back to those just later to clarify this section. But let's look at sample spaces. Two things happening in a row. Write down all the possible combinations of outcomes from related events. You're having a two-course lunch. You're having a starter and a main meal. Or you're having a main meal and a dessert. There are two things happening in a row. So a two-course lunch offers a choice of 3 starters and 4 main course lunches. How many different combinations are there in total? 3 starters and 4 mains. Starter 1, starter 2, starter 3. In terms of main courses, main 1, main 2, main 3, main 4. How many different outcomes are there, or combinations are there? You might say there's 3 here and 4 here. You'd say there's 7. But really what we're saying is we're patterns here. We're patterns of people, and we're saying everybody's going to have both a starter and a main. So what could be one possible outcome that might happen? Could somebody take starter 1 and main course 2? Or starter 3 and main course 3? Yeah, and if we multiply it out, we'll say it's possible this person here took starter 1 and main course 1. This person here took starter 1, main course 2, starter 1, main course 3, and starter 1, main course 4. But starter 2 came in there as well. So this path here was starter 2, main course 1, starter 2, main course 2, starter 2, main course 3, and starter 2, main course 4. Are there any other possibilities? Yeah. So we have also starter 3, main course 1, starter 3, main course 2, starter 3, main course 3, and starter 3, main course 4. How many different outcomes do we have now? 12, is it? Are they all different? What did you have? Well, I had the same starter, we didn't have the same meal. Everybody here in this position here had something different. Not one of those is the same as another. Is that okay? Either the starter is different or the main course. How many items are there, if we count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should we be surprised that there are 12? Not really, because how many are here? 3. How many are here? 4. And 3 by 4? 12. So that seems to be multiplication, doesn't it? Yeah? So in that case, we're saying this and this gives us and that is and if I go back, it says that the fundamental principle of accounting under and is you multiply. Is that okay? And there's an example of the menu. Starter, main course, and dessert. 3 starters, 4 mains, and 4 desserts. You'd have 3 here, 4 here, and 4 here. How many different patterns would you get out of this? Would you again multiply? Well, 48, because if you think about it here, this person who had started 3 menu, main course 4, there's no restriction on what dessert this person might have. None on this person either. So we'd multiply again, and 4 times 12 would give us 48. So there are 48 different choices out of all of that. Because we're having both a starter and a main and a dessert, all of it. Is that okay? So the total number of possible combinations then, and the combination is that the order doesn't matter. I'm going to have a starter. Well, I suppose you should eat the starter before the main, but as long as I get them, what did you have? 3 by 48. What's the chance of a diner choosing a particular lunch combination? What's the chance that a diner will pick? Let's go back. Say, what's the chance that, I bet you he's going to pick starter 2, main course 1, and dessert 4. What's the chance of that happening? If you didn't know the person at all now, you have no inside clue on the person. Chance here is 1 in 3, isn't it? Chance here, 1 in 4 and 1 in 4. A third by a quarter by a quarter. Third by a quarter is a 12th. 12th by a quarter, 1 in 48. So we're now down to 1 in 48 chance. So we say it's 1 over 48 is the probability of starter 2, main 1, dessert 4 is 1 over 48. Why is it 1 over 48? Because the total number of outcomes on the bottom is 48, and there's only one of them that matches starter 2, menu 1, dessert 4. Is that okay? That's to do with the word and. Let's go back and imagine that this was S1, S2, S3, and C1, C2, C3, C4. And just imagine that the letter S stood in this case for sweets, and C stood for chocolates. Right? And on a plate, somebody says, 3 sweets, 4 chocolates. Take one. Select one. You don't say, I took one of each. No, just take one. Is that okay? You're allowed something or something else. You can't take a sweet and a chocolate, just one or the other. Is that okay? How many choices do you have now? 7, because you could take any of these or any of these. You could take any from this or any from that. You have 7 choices, because the word is or. Is that okay? So you've got to really ask yourself, what's going on here? Is that an or, is that an and? Have a choice? Have to do both? And once you bring in those questioning from outside world, you'll use the right equation and it'll work. So independent events. What is an independent event? It is important in this part that we find out, is the event independent? Because if it's not, we have to figure out a different probability. So an independent event is defined here is if the outcome for the first event does not affect the outcome for the second event, then the two are independent events. Example, a deck of cards contains 52 cards. A card is selected at random and then put back for a second card to be selected. What's the probability of getting a black club followed by a red card? Now, I want to figure out, I have a deck of cards. How many cards are there? 52. So let's say I've got the clubs here. I've got spades. I've hearts. And I've diamonds. And I start off with 1 to 13 here, ace to king, or 1 to 13, let's say. I want to figure out what is the probability of getting a black club followed by a red card. A black club. How many clubs are there? Are clubs black? So what's a black club? It's a club, isn't it? It's like a red heart, isn't it? If they said black heart, I wouldn't have much of a chance, would I? No, but so that's just a, thanks for the confusion, that's just a club, isn't it? So a club then is, what's the chance of getting a club? I could say 1 in 4, couldn't I? But really I could say 13 out of 52, couldn't I? That's the probability of a club. Followed by a red card. Are these red over here? Okay. So what's the probability of red? 26 over 52. Is that okay? Now, what's the chance of, now, if I put the card back, what's the chance that the first card will be a club? This is P club. P of club and red. Is that okay with me? What's the probability of getting a club first? 30 over 52. What's the chance of getting a red? 26 over 52. This is the first one, this is the second one. I might multiply them by each other or whatever, but would it be different if I didn't put the club back? If I didn't put the club back, how many cards would there be left? 51. So would I have a better chance of getting a red then? Yeah. So that's really where this is about. I've got to remember that, I know they're independent. The first one doesn't affect the other. Is that okay? So that's what the concept here of independent is, that the first black club is 13 out of 52 and the red card is that. Black card, then red card. You multiply them together by each other and you get your answer. Is that okay? That's a simple, independent event, pure, and you can do simple calculations. When they're not independent, the formula just gets a little bit trickier. But that's the end of that topic where we're talking about two events that are independent and we're working out the probabilities.